Hello everyone, I'm Sonam Norbu and I'm currently working as a KTP Associate on an exciting Innovate UK Knowledge Transfer Partnership project between the University of Glasgow and the Crichton Trust. The project is led by Professor David from the University of Glasgow, who serves as my knowledge supervisor, and Jennifer, the head of research and development at the Crichton Trust, who is my company supervisor. We are also well supported by Jim, our KTP advisor, and an amazing team from the west of Scotland KTP Centre. Well, the Crichton Trust is a social enterprise and heritage charity dedicated to preserving and enhancing the Crichton Estate, a historic site with over 160 SMEs spread across 27 buildings and 85 acres of heritage parkland, located at Dumfries, the south of Scotland. Our project addresses the complex challenges of decarbonizing the diverse assets by developing a building and energy data architecture. Philosophically, I like to frame our work as clipping off the embodied carbon from sandstone heritage buildings. This is an overview of my presentation today. The primary objective of the KTP project is to leverage cutting-edge digitalization strategies to achieve operational optimization and carbon reduction. These are the major challenges addressed in this KTP project. In our approach, 2022 serves as the baseline established through the Crichton State Carbon Footprint Analysis. Our target is to achieve net zero by 2030. Buildings, particularly their heating systems, were identified as the most carbon intensive. Consequently, this KTP project focuses on building decarbonization. To decarbonize heat, we propose the adoption of renewable low carbon sources primarily through a district heat network supplemented by innovative plug and play heat sources such as hydrogen, biomass and waste heat. Additionally, we aim to reduce operational consumption through building fabrics improvements and the integration of low carbon generation to offset increase electricity demand from technologies like the heat pumps. However, the district heat network requires further study, especially considering the challenging of transitioning heritage buildings to low temperature heating systems. Fabric upgrades are costly and moreover, Crichton faces unique challenges with its heritage listed structures. Therefore, our focus in this KTP project has been on exploring the fine-tuning and low-cost interventions with an emphasis on digitization for decarbonization. We are currently innovating digital services to prepare the entire state and the community as a whole for a low carbon network transition. Now, let me walk you through the cyber-physical energy system architecture we have implemented at the Crichton Trust. It mainly consists of four distinct layers. First, we have the asset layer where all the physical sensors and monitors are deployed. Moving up, we come to the integration and communication layer, which converts physical signals into data and transmit them via various communication protocols. Third layer is the information layer responsible for data conversion, storage, and visualization. Finally, we have the function layer, and this layer is divided into two parts. First, the standard functions such as machine learning and non-expert services, and the second is the expert functions which perform more specialized tasks. By separating computationally intensive standard functions from the expert functions, we have optimized hardware usage and improved maintenance efficiency compared to the traditional methods. Now I will present the web portal developed for the Crichton Trust built on our cyber physical energy system architecture. This is a comprehensive web portal that we have developed for the Crichton Trust. All the sensors and monitors that we have established at the Crichton Trust are the overview of that has been described here. So you can see all the sensors and the monitors that we have along with the data resolution that we are monitoring at the moment. And this shows the exact physical location of the sensors and the monitors and all the digital assets that we have for the Crichton. So any planners or any state managers, they want to know exactly how we have placed and where the placements are, then they can zoom into it and then look into it. For instance, this is the building that I'm exactly in right now. So here you can see different digital assets that we have in this building that we are looking at. So this is the live thing. So even looking at the coverage, you can see that actually the LoRaWAN is quite amazing, that we are able to cover quite an entire area. And then this is an area that we have a real-time visualization of the data that we are monitoring. So we can see that we have the indoor environment monitor, gas boiler monitor, and the outdoor environment monitor, along with the dedicated weather station and air quality monitor. And then building-wise, so we have looked into it and segregated into the carbon-intensive buildings that we are monitoring, and then we have a building-wise monitor. So for instance, if you look into it, this shows the indoor parameters of all the buildings that we are monitoring right now. And here we can see that, for instance, this EB14 corresponds to a swimming pool. We have one swimming pool in one of the buildings. So that's why the room temperature is always high. So that's why you can see that it's always constant. So we are measuring room humidity, room occupancy, motion detected in rooms, light in the rooms. Here with the help of this one, so this is exactly the live data that is coming through the boilers that we are monitoring. For instance, this is the boiler that is, so whenever somebody turns on the space heating or whenever the hot water is on, so that means the power is on, and this is where, so right now the boiler is on for this case. Now if you look into in this case, for instance, in the charged boilers, right now the charged boilers is turned off, so that's why the power is off, and then the energy remains constant, right? So as and when there is somebody turns on the space heating or hot water is on, then there will be a power consumption, then the energy will increase. So this is exactly the data that is coming through that one. And then this is the data that we are monitoring real time right now through our weather station data. And then this is the data that we are monitoring through our air quality monitor that we are looking at right now. One can directly go and specify from here or visualize it from here, or one can also go it specifically to this dashboard, and then we have defined all the parameters here. For instance, in the specific building that we are looking at, so for that building, so we can visualize what is it. So for instance, this is the temperature, and then we have segregated even in the floor wise, second floor, first floor, ground floor, and then embedded it with the outside environment parameters and gas boilers data that it is coming through. And then to be more accurate, and we want to be absolutely sure that the data that is corresponding to which part of the room, which floor. So for that, we have exactly the coding that we have here, and this coding corresponds to the location of the sensors that we have. So if somebody really are confused and they want to know exactly which part of the room that we are corresponding, so this coding will correspond with the code that we have here, and we exactly know which room that the sensors are being placed. So we have brought the floor plan into it, and then exactly somebody can point out and see where the sensors are being placed. And we can also download the data, and then data is mostly available in the CSV form, and then almost all the digital twin and the digital services that we have developed are being made available from here, and then one can access through it. Next, I will highlight on 2 digital services we have developed to improve the system efficiency. The first service optimizes boiler settings to support future low carbon technologies like heat pumps without retrofitting, while the second service tracks boiler operation and triggers alerts for the inefficiencies. Using these digital services, it enabled us to reduce boiler maximum operating temperature by transitioning to low temperature operation. To achieve this assessment, we first monitored the business as usual situation to have a basis to compare with. Then we progressively adjusted the gas boiler's flow temperature and operating times, while monitoring the indoor and outdoor temperature and humidity for the entire test period. We could reduce the flow temperature initially operated at 90 or 80 degrees Celsius to 50, aligning it closely with the temperature achievable through the renewable heat sources. We observed 15 to 28 reduction in gas usage by lowering the maximum flow temperatures. Using our CPS system, we track the building's thermal behavior, specifically variation in the indoor and outdoor temperature and humidity, and despite just having a single glazing, it showed a positive thermal performance under low temperature heating. If replicated across our entire state, this could yield significant cost savings and reduce our carbon footprint. This study has already influenced plans for a district heat network benefiting both the Crichton state and the wider community. Our efforts have already established credibility, enabling the Crichton Trust and the University of Glasgow to host a stakeholder meeting for our whole system and regional net zero planning, demonstrating our proactive approach to driving innovation in the region. In the academic domain, we have submitted a journal paper on smart local energy systems to the Advances in Applied Energy Journal. Currently, it is under review. Additionally, we have submitted the full paper for presentation at the upcoming Net Zero International Conference organized by the Institution of Engineering and Technology. Our KTP initiative has been instrumental in fostering collaboration with various projects and stakeholders. Our CPS facilitated a partnership with the University of Glasgow's CSI Research Group for Smart Space Management. We are also exploring the replication of our work at the University of Glasgow's main and extended campuses. A team from Napier University has visited and agreed to replicate our work, particularly in the implementation of heat and flow sensors for gas boiler monitoring and in developing a common testing framework. In addition, we are actively collaborating with SIT Singapore and ASC from University of Glasgow on common platforms for digital twins and designing resilience in cyber physical energy networks, building on the foundation we have established here at the Crichton Trust. The KTP project has also actively engaged with the researchers from various EPRC funded projects. My special thanks to our knowledge supervisor for facilitating these connections. Indeed, I had an amazing opportunity to be an ambassador of the Crichton Trust and the University of Glasgow. During this KTP period, I contributed as a co-author to 4 journal articles and 4 conference proceedings. I made sure to plan and use my KTP professional development budget wisely, as it is a key part of the project that really supports both personal and professional growth. This was mandatory modules, and I must say that I learned a lot from it. Overall, I focused on general skills, especially in innovation strategy and storytelling aspects. Rest, I mainly focused on technical skills closely tied to my core responsibilities. On the professional side, I am now a full member of both IEEE and IET, which further strengthens my standing in the field. In terms of recognition, I'm pleased to share that our team was nominated by the University of Glasgow for the Scottish Knowledge Exchange Award. While we applied, we unfortunately did not win. However, I'm excited to share that we are one of the finalists for the Innovate UK KTP Award 2024 under the Future Leader Award category. Indeed, we applied for 3 categories and we were selected for 1. Looking forward, we are still eligible for more future awards, hopefully many more to count on. Moving forward, we plan to continue our efforts in enhancing digital services for the Crichton Trust. We will be collaborating to co-develop a common testing framework exploring how traditional buildings can transition to low-level heating sources and heat networks. Additionally, we aim to complete 3D modeling of the buildings to create a comprehensive digital twin. Beyond the KTP project, our work will be supported by the EPRC-funded HIACT project at the University of Glasgow, in which Crichton Trust is an industrial partner and a demonstration site where I will continue my role. This ensures a smooth transition from the KTP to the future initiatives. Once again, special thanks to our knowledge supervisor, Professor David, for the support. Well, last but not the least, I must say this journey has been incredibly exciting and enriching, and I would like to sincerely thank everyone involved. With this, I conclude my presentation. Thank you all.